Hello and welcome back. In this video, our goal is to use the fundamental theorem of calculus to find the following definite integrals. And again, the fundamental theorem of calculus says that the definite integral of the function f of x is equal to the antiderivative at the upper bound minus the antiderivative at the lower bound. So for our first problem, we have the integral from 0 to 6. Let's write that over again. Integral from 0 to 6 of 2x plus 4 with respect to x. So first thing to do is find the antiderivative of the integrand. So using the power rule, we know that's going to be x to the second power divided by 2. So that's going to be x squared plus 4 times x. We do not include an arbitrary constant on these problems because it always cancels out in the calculation process. So this antiderivative is evaluated from 0 to 6. So that's going to be equal to 6 squared plus 4 times 6 minus 0 squared plus 4 times 0, which we know is going to be just 36 plus 24, which is going to be equal to 50. So that integral is equal to 50. And we saw that earlier in a different video with using area to find this integral. For the next problem, we're going to be looking at the integral from 0 to 2 of x squared dx. Once again, we're going to use the fundamental theorem of calculus. We add 1 to the power and divide by that new power. So that's going to be x cubed divided by 3. Evaluated from 0 to 2. So that's going to be 2 to the third power divided by 3 minus 0 to the third power divided by 3. And that's going to just make 8/3. That is another problem that we saw earlier. We used Riemann sums to figure this out. And then finally, something a little different. It's going to be the integral from 1 to 4 of 6 times the square root of x with respect to x. So that antiderivative or integral is going to be 6. And again, that's x to the 1/2. So when we add 1 to the power, it's going to be x to the 3/2 divided by 3/2. No arbitrary constant needed. Evaluated from 1 to 4. When we take the reciprocal and multiply, that's 6 times 2/3. And this is going to be the square root of x cubed, evaluated from 1 to 4, which is just going to be 4 times the square root of x cubed from 1 to 4. So that's 4 times the square root of 4 cubed minus the square root of 1 cubed. So that's going to be 4 times. Square root of 4 is going to be 2. 2 cubed is 8. Square root of 1 is 1. 1 cubed is 1. So that's going to be 4 times 7, or 28 for the value of that integral. So those 3 different definite integrals that we calculated, we're using the fundamental theorem of calculus to get each one of them. And once again, you find the antiderivative of the integrand, function inside, then evaluate it at the 2 endpoints and subtract, take their difference.